So you guys might recognize this generator that I use as probably one of the more important instruments on the bench that I own. It is a vintage RF generator, the HP606B. It's the last of the 606 models. These date back to the mid-60s, and this is the last of it. The 606B, I think I see dates around 1970 on this unit. Anyway, it started to get symptomatic with hum, and the modulation wasn't working right, and I had a feeling that maybe the capacitors inside were going bad. My next project is supposed to be a ham transceiver, a refurb, and you really can't do that unless you have a good generator. So I had to dig into the 606 and recap it, and this involved around 6 or 7 electrolytic capacitors. So I had to tear off the plates and go to it. But it's good to have this thing back on the bench, that's for sure. So the other thing you might notice with the generator is a funny line going through it. And let me turn this receiver down a little bit. The dial, as you can see, has this line going up through it. And what that is that's the applique that went on the front of the metallic platter. And basically it started lifting off. It was just put on with glue apparently. And it started shrinking, some kind of plastic or something. So I had to get in there and use some glue and glue that back. While I was inside, you know, taking all the covers off and everything on the generator, I thought it would fix every little thing that was bothering me with it to get this thing back up to snuff. So it's important to once you actually take the time to fix an instrument like this, to fix all the small things, get all the lubrication done, contact cleaner and all that stuff. And now the generator will be alive for many more years. Okay, very happy to have my generator back, let me tell you. There's certainly more modern generators with digital outputs. There's synthesizers and even single chip direct digital synthesizers and you know, much more modern ways of generating signals. But when you're working on vintage equipment, it's a lot of fun to use a vintage generator like this, and you get used to it. And it's a terrible thing when a key piece of equipment goes down in the shack. But all it needed was really some new capacitors and a little touch up on the alignment, and it's back in operation. You might also notice that I picked up a little bit better oscilloscope. It's a BK Precision. It's not a high-end oscilloscope, but it's better than that leader scope I was using, and it gets me up a little bit in frequency, has more features. So still a vintage piece, but nice to have a good oscilloscope on the bench. If we talk about the generator having a long lifespan of the late 50s through the early 70s, you can imagine that's a tremendous period of advancement in electronics. The style of construction changes during that time. We go from vacuum tube type power supply regulators to solid state. We go from point-to-point terminal strip and conventional tube socket wiring point-to-point to printed wiring boards. And these generators go through all of those stages, going from the 606 to the 606A to the 606B. You're going to find completely different styles of electronics inside. You know, some of the early ones you might see a calibrator that looks something like this, and in the later one the calibrator will be on a printed wiring board. So I know the regulator transistors went from germanium to silicon in a lot of the power supplies. So this late model even has an IEC, a standard IEC connector, if you can believe that. So it's that modern. But the general circuit using the tubes in the differential fashion with the RF feedback and automatic leveling is maintained throughout the series. So they don't get rid of the tubes in the functional part of the generator, which is very important to understand. Now, you might find that the older style is easier for you to work on because you're used to complete tube-type circuits with point-to-point wiring. Or you might find that you like the printed wiring style with the tube sockets mounted right on the printed wiring board, and that's easier to troubleshoot for you. But in either case, you want to look over the circuit boards and look at the resistors very closely to see if any of them are discolored, perhaps have been over-dissipated, because I have found that this thing will not align properly if the resistors have taken abuse and they've gone out of value, because this is a full feedback type circuit, very difficult to troubleshoot because it's a closed loop type system. And you have to start with having the values correct and the voltages correct before you go any further. Let's take a look at the block diagram of the HP606. And this goes for pretty much all of the models. First of all, we have an RF oscillator that is leveled. This is interesting because as you go from band to band, the oscillator is able to self-adjust through bias, and it remains fairly constant as a driving circuit. There's also a varactor tuning assembly on the RF oscillator, which allows you to do external sweeping, like sweeping an IF transformer to tune it critically, or to put in direct FM modulation. Then we have an untuned buffer amplifier, which provides an uncalibrated RF output that you can use, for instance, to drive a counter, and then an RF amplifier, and a calibrated RF attenuator. And this is a high-quality laboratory-grade attenuator. There's a modulation circuit that provides both internal and external AM modulation, and it also acts to level the output in a second feedback loop. This loop takes samples of the output energy and puts it back into the modulator, so the modulator simultaneously acts as an RF carrier leveling control and an actual modulator for AM modulation. And finally, on the output, we have a crystal calibrator, and you can use that with headphones to set your cal points with a dial corrector on the front of the generator. Let's take a little bit closer look at the oscillator. As you can see, it's a push-pull type oscillator. This might be called a tune plate push-pull or a push-pull Armstrong oscillator, and it has level control on the bias that keeps the level somewhat constant as you switch in the turret assembly from band to band. This keeps the drive somewhat constant into the buffer stage. You also see some varactor tuning, and it's balanced. It's a differential style varactor tuning for external FM. That external FM can also be used to phase lock or frequency lock the oscillator through an external instrument, which allows the generator to actually be frequency locked. Now, working to the right, we get into the push-pull buffer. This is an untuned buffer. It does have a cathode follower transformer that allows for an uncalibrated RF output. This can be used in conjunction with a frequency locker or you can put that into a counter. It's a useful tap. Using a buffer here also is good because it breaks up the possibility of a tune plate tune grid oscillation in the amplifier stage. So this stops the feedback capacitance between the grid and plate of the amplifier. So with push-pull you double your voltage swing, so this thing really can put out quite a powerful signal into 50 ohms with the turret assembly's secondary tap. Going down into probably the most interesting section, the modulator and automatic leveling control circuit, which samples some of the output on the turret assembly, brings it back into a differential amplifier that is used to set the bias in the modulator, which is a 12B4 tube that acts as a cathode modulator for the push-pull amplifier. The other side of the differential amplifier is where modulation can be introduced, and that also acts to control the DC resting current. So think of this modulator as both a DC and an AC system with automatic leveling control and modulation within the loop. The audio oscillator is a modified wine bridge style, low distortion type audio oscillator that's used to provide the AM modulation. There's an AM modulation monitor. It's basically a detecting cathode follower that takes a sample of the audio and gives you a percentage modulation. And typically most of our work is done at 30% modulation for standard receivers. And then down below is the calibrator system. This is the basically the transistorized version, and there's a beat frequency output amplifier that drives the headphones. And it's funny because they had an extra section on the 12AT7, so they kept that, and that's what drives the headphones. And you're basically looking for zero beat on the calibration marks. The modern power supply using silicon transistors and Zener diodes for references. We have a positive 300 volt supply and a negative 200 volt supply and a 25 volt DC supply. Interestingly enough, the negative 200 volt supply is almost identical to the positive 300. The circuit really doesn't care where you take the current, so they simply grounded the positive side of that regulator, and you end up with the negative 200 volts. And it's a very conventional type regulator system with differential amplifier and feedback. So the HP606 generator is a very popular set, and there are probably thousands of them out there. And you're going to find a lot of information online and YouTube videos and so on. The first thing you need to do is to obtain the service manual, which is readily downloadable from several sites. And this is really widely supported. I limited my work to simply replacing the power supply electrolytics. There probably were 5 or 6 smaller electrolytics that I ignored, so I could have gone a lot further. Again, the most important thing is to check the voltages with the voltage chart and resistance chart. It's the most important thing in the manual, and that will give away where the problem is. Usually a resistor that's drifted out of tolerance. So my work was really limited to replacing some electrolytic capacitors in the power supply sections. I could have gone a little bit further. I did mount some terminal strips inside to hold the new capacitors safely, and I had to extend some of the wires that went to the old electrolytics. So I just cut the leads off the old ones that were inside, extended the wires to the terminal strips, and put the new caps in. A pretty straightforward conversion to put the signal generator back on the air.